Welcome back to our system design series. Today we are diving into another important caching strategy known as read-through cache. This approach is great for optimizing read-heavy workloads and ensuring frequently accessed data is always close at hand. So, what is exactly a read-through cache? So let's just take a small example so we can understand what's a read-through cache. Let's say that we have application, our own application, and the cache and the database. As you can see here, the cache is in line with the database and the application. So in the read-through cache strategy, the cache sits in line within the database. This means the application interacts with the cache, and the cache itself handles any communication with the database when necessary. Essentially, the cache acts as a smart intermediate between the application and the primary data store or the database. So, how it works? First, when the application requests the data, it first checks the data in the cache. Okay, if the data is available in the cache, that's we call a cache hit, and the data is returned immediately to the application. However, if the data is not available in the cache, which we call a cache miss, the cache automatically fetch the missing data from the database. It will try to fetch it from the database. After retrieving the data from the database, the cache populates itself with the data and then return it to the application. So basically, when the data is returned back to the cache will return the data back to application, and also it will store it in the cache for future uses. The key benefit of this approach is that the cache manages its own population. The application does not have to worry about querying the database directly if there is a cache miss or a cache miss or any other problem. The read-through mechanism handles that automatically, and it makes it really easy to understand. And actually, it makes it like, since the application doesn't have to worry about how the cache works, it's less there is no like complexity with it. So let's consider an example, a real world example, to understand what's going on. So let's assume that we have um, let's say that we have a newspaper website that serves millions of users. So let's just add, let's make the cache here and that it be like that. Okay, and let's add the client. So let's say that we have like millions of clients trying to send trying to send requests to our news website that serves millions of users. So, and when a client try to like request like an article or something, instead of requesting each article directly from the database, we can do something better. Like, instead of querying the database for every article request, the read-through cache sits in between the application and the database. When a user requests an article, the application checks the cache first. If the article is there in the cache, it returns it quickly. If it's not, the cache will load it from the database, serve it to the user, and store it in the cache for future requests. This ensures that popular articles are cached and can be served with very low latency. So this is how it works. When you try to get an article, we'll see first in the cache. If it's in the cache, it will be returned. If it's not in the cache will fetch it from the database, and the database will return it back. The cache store the data and return it to the application, and the application return everything to the clients. This is how it works. Um, let's understand what is the benefits from using a read-through cache. The first thing, it's it simplified the application logic. It's really simplified the application logic. I'll try to make it with numbers because this will be better. Yeah. So it's really important when it comes to simplified application logic because it's really way more easy. Like unlike cache aside, where the application must explicitly handle cache population in read-through cache, the cache manages itself. The application simply reads from the cache and does not have to worry about whether the data is in the cache or not. The second thing, which is a great benefit, which is the automatic population when whereas a cache miss, the cache itself takes care of querying the database and storing the result, ensuring that frequently accessed data is available for future requests. We can next talk about the drawbacks, and first we can start with the cache miss penalty. Like just unlike cache aside, just like cache aside, the first time a piece of data is requested, there will be a cache miss that involves fetching data from the database, which can be slow. To mitigate this, developers can use like cache warming to preload commonly accessed data. Also, we have like no custom data models because yeah, there's no controls of the cache. Unlike the cache side strategy where you can create a different data module for caching, read through cache requires that the cache data have the same structure as the database data. This means less flexibility in optimizations, in optimizing how is stored in the database. Um, if you want to understand when to use the cache aside, I would say there are three conditions. First, if you have a read heavy application where you expect the same data to be frequently accessed by multiple users. If you have systems where you, I guess, if you want to simplify application code by letting the cache layer manage itself, it's also a great reason to use read through cache. Also, use cases where cache misses are acceptable during the first read, but subsequent requests should be as fast as possible. So that's it for this video, and yeah, if you found this video helpful, please make sure to subscribe and hit the notification bell so you'll never miss a video, and see you in future problems.